Good morning, everyone. It is morning for me. I don't know when you're watching this. It could be 1 in the morning. It could be, 8 p.m. at night, but it's morning for me. So good morning, good day, good evening. We're going to be talking about section 2.5, linear functions and models. So lines are very important in math. And although you might see it one way, you might see it here another way, they all mean the same thing. So kind of being able to just see that there's many ways to write the same thing can be very important, like kind of a good thing to see. So a function of the form y equals mx plus b is called a linear function. So you heard me say y equals mx plus b. This definition is of course saying f of x equals mx plus b. You might know it as y equals mx plus b. That is exactly the same thing. Y is the output in my definition. F of x is the output. It's still just, the output value no matter what. Our book actually uses a instead of m. So like you might see if you're reading the textbook, ax plus b. So in the end, they all mean the same thing as long as you focus on the fact that x is the independent variable and y is the dependent variable, or f of x is the dependent variable, depending on what you see. So the x and the y, or the input output, should be the same. Any other number you see is a constant. It might relate to something, but it's just a number. So that's, maybe something we can kind of talk about as we go through this. So what we're being told here is when 0 is put in for the independent variable, so for x, we should get b. And that means that b is what happens when x is 0, which graphically speaking means that b is the y-intercept of the graph. So what that means is you have the point 0b on your line. M is the slope. So again, if you're reading the book, they're going to put an a next to the x, and they're going to say that a is the slope. But the important thing to understand is it is the value that is next to the x. It is the value that is next to the x. No matter what letter it is the value that is next to the x. When you have something of the form f of x equals 2x minus 3, you are in slope-intercept form. And what that means is some really good stuff, because you know a lot about your graph of your line when you have that in that form. So when you have f of x equals 2x plus 3, the slope is that m, that value next to the x. It's 2. You could also write that as 2 over 1 because of the way slope is, which I'll talk about in a second. Y-intercept here is 0, comma, and then notice because the form is mx plus b, in this case you want to think of it as plus a negative 3. So that tells us that negative 3 is the y-intercept. So that's just an example. That's not the picture that you're seeing. The picture that you're seeing is just showing you a line, an example of a line, specifically y equals x. Slope. Okay, so slope, as you can see here, is denoted by m, and it is the rise over run. And all that means, it's the change in the y values from one point to the next on a line over the change in the x values. And it doesn't actually have to be 2 points that are right next to each other. It can be any 2 points. If you remember from previous, lines have a constant rate of change or a constant slope. So it doesn't matter which points you pick, the slope between them will always be the same. So for example, if you're thinking about here, the idea is, think about basically this here. So the slope is, how steep the line is, and this line could be here, the line could be really steep and not steep at all. And the way to find out how steep it is by doing rise over run. So to be very specific, the idea is here's a point x1, y1, here's a point x2, y2, and your slope is the difference between these 2 points, which are that distance, I should say, which is a difference in the y values, y2 minus y1. And then it's divided by this difference here, the distance from that, and that's x2 minus x1. So y direction, x direction. So if you find the ratio of that, that is your slope. And most students will know this already from their algebra days. But let's take a look at an example. Find the slope of the line which contains the 2 points, -3, 1 and 4, 5. So if you want, you can take a moment. You're just going to be using the formula that you see right here to come up with it. So you could do that and then unpause and see if you get it right. So understand that I can actually choose either point to be x1, y1, x2, y2. I will go with 5 minus 1. So this will be x1, y1, and this will be x2, y2. But I have 5 minus 1 over 4 minus a -3. And then I just simplify. So I have 4 divided by 7, and literally that is it. So if you have, you're welcome to, maybe take a look at this on a graph or something like this, but all it means is that if you are going from one point to another point on the line that contains both those points, you're going to go up a +4 and over a +7, and then your line is going to have a slope that looks like this. Okay, so properties of slope. We've talked a little bit about some other stuff that should relate. If your slope is positive, that really just means that your line is doing this. And that means that the line is increasing. And we've talked already about functions that are increasing, but we can imagine that if our slope is positive, we're going to go like this. If the slope is negative, so if m is less than 0, it's going to go down. And so not surprisingly, that will be decreasing. You might be able to guess if m equals 0, there is a slope that is 0. And what that really means, if you think about it, is that the numerator is 0. So the change in the y values is 0. So that creates a line that looks like this. And you might be able to kind of get an idea of what that line looks like. We've talked a little bit about it already. It is horizontal. And it's a constant function. So we've talked a little bit about those. F of x equals c. It means that you have the same y value all the time, so the difference in the y values is 0, and that creates a line that's horizontal. So I did put it there, f of x equals c, but I'll write it again. In general, what it means is, another way to write that would be y equals b. So I know that there's a lot happening there, but this is what we saw in an earlier section. Y equals b is just basically showing that b is the y-intercept, the y value of the y-intercept. So that's another way to look at it. If m is undefined, so if m is like you cannot define the slope, that means that the line is vertical. So typically what that means is the change in the x values is 0, which means that you always have the same x value. So that's creating a line that looks like this. It's just straight. And in that case, it would be x equals, some value, whatever the x value is, and that would just be a constant. So again, it can be anything. I'm just trying to think of the variable that I want to use here. I guess I'll just use c because I used it before. And c is just a constant. So c is a constant. So for example, x equals 5 just means that you have a vertical line at x equals 5, so that the y values can be anything, but x is always 5. Now, if you have a point on a graph and that line has slope m, then another way to write the equation of the line is y minus y1 equals m x minus x1. Now, understand that that is, if I divide both sides by x minus x1, I have a version of the slope. So it's just a modification of the slope formula. but it is another way to write a line, and it is called point slope form. So what it tells us is that, which is kind of great, is that if you have a point and if you have the slope of the line, that's all you need. If you have the point and a slope, you can find the equation of any line. Two things you need. So we're going to find the equation of the line from before. So number one is we need the slope. We have the slope of the line. We found it in the last example. That was 4/7. So I'm the example from the middle of the page. We already found the slope. We need a point. We have that. We can actually choose either point, just so you know. In slope-intercept form, your answer, there's only one way to write a line in slope-intercept form. So you can choose -3, 1 or 4, 5. Let's say I just want to deal with positive numbers, so I'll pick 4, 5. Again, you can pick either one. And then what I'm going to do is I'm going to use my point slope form. So again, as long as I have slope and a point, I can always find the equation of a line. So y minus y1, our y1 in this case is 5. You're free to pause and do this yourself if you'd like, and then come back. I'm going to write it in the form y equals mx plus b. What I want you to see that I've done here is I've put my point on x1, y1, and I've put my slope on m. So now I'm just going to distribute. So I'm going to have -16/7. So that's 4/1, so it goes into my numerator. And then we need to add 5. So plus 5 plus 5. And then I'll bring it up over here. And we will end up with y equals, and notice we have our slope there, 4/7 x. And then I'm going to add -16/7 plus 5. So I'll do that over here for anyone that wants to see it, who might not be using their calculator. So we just want to write 5 with a denominator of 7. So 7 times 5 is 35. So notice 35/7 is 5, but it allows me to add the two fractions together. And when I do that, it looks like I'm going to end up with a positive 19/7. Yes. Sometimes we get fractions. Lines and most stuff in math is not always pretty. We do a lot of like kind of nice number stuff. But in this case, we have a slope of 4/7. We actually have a y-intercept of 0, 19/7, or it looks like that would be 2 5/7 as the y-intercept. But our job was just to find the equation of the line and write it in slope-intercept form, and we have done that. So a little more about slopes, because it's important for lines, is that two lines with slopes m1 and m2 are parallel if and only if the slopes are equal. So it just means that, and again, let's see how well I do. Okay, not too bad. So lines are parallel if their slopes are the same. And you can see that if you're moving, your rise over run is the same, you're going to create two lines that never touch and therefore are parallel. You can also have two lines that are perpendicular. Now, two lines are perpendicular basically if they meet at a 90-degree angle. So you have something that looks like this. They got to meet at 90 degrees. So you'd have 90 degree, 90 degree, 90 degree, 90 degree, like that. Maybe I can show it with this. So here's our perpendicular, but arguably they could be any way as long as you have that 90-degree angle between them. And you know if you have that if m1 equals a -1/m2, or, oops, let me move that m2 down. I want that, I'm thinking squared, I don't know why, it should be m2. And so that's going to be down here. Yes, down here, which is the same as m1 times m2 equals -1. So either way you want to slice it, that's what it means for two lines to be perpendicular. So let's take a look at an example. Find an equation in slope-intercept form. No surprise there. That is very typical. We want to finish it off as y equals mx plus b, so solving it for y, of the line through 2, 3 and perpendicular to the line with this equation right here. So remember, we need two things. We need point and slope, and usually I tell students, are either one of those things staring us in the face? Is the point staring us in the face? Is the slope staring us in the face? And most students will look at this problem, hopefully, and say, hey, I see the point we need. There is a point on this line that we're trying to find, and it is staring me in the face, and it's 2, 3. We don't, however, have the slope staring us in the face. Doesn't mean we can't find it, it's just not staring us in the face. So the slope that we need is going to come from this line. But notice it's not in slope-intercept form. When a line is in slope-intercept form, you can see the slope right away. But luckily, you can always take a line, even in this form, and write it in slope-intercept form. So the way to do that is to rewrite this by solving it for y. So if you want, you can pause, take a moment, and solve it for y. All right, so I'm doing that now. So it looks like yes. Okay, so now I have a line that I want to be perpendicular to my line. So notice this line right here is not the line, it does not have the slope I want, but it has the perpendicular value of the slope that I want. So what we need to do, so what we have found now is that m1 equals -2. So the slope that we have is -2, but we want the perpendicular. So what I want you to see, there's these formulas up here with number 7, and I see that. But I want you to understand it's just the negative reciprocal. So the way to think about it is m1, which is -2, needs to be -1 over m2. You could do it like that, and you could solve it. That's one way to do it. It might be easier to do the second one that I showed you there in number 7, which is that m1 times m2 needs to equal -1. And then if we just divide both sides by -2, you can see that we get 1/2. So that's actually the slope that we want, is 1/2. So our line should have a slope of 1/2. It should have a point 2, 3 on it. So now we are able to write using point slope form. We have everything that we need. We have the point and we have the slope. So if you want, you can pause, try to write this in point slope form, and then solve it to put it into slope intercept. So I'm going to take my point like this, and then I'm just going to solve. So looks like this one, not a whole lot of fractions, yay. Adding 3. So we end up with y equals 1/2 x plus 2. So this line is perpendicular to this line because their slopes are perpendicular to each other. So that creates lines that are perpendicular to each other as well. So just for anyone interested, these are the 2 lines from the last problem that we did. And you can see that we have 4x plus 2y equals 3. That's the red line with a slope, remember, of a -2. So that's what's happening here. And then we have our slope, our line in slope intercept form that we found, the perpendicular line, y equals 1/2 x plus 2. That's the blue that you see here. And the idea is that those 2 lines should meet in a perpendicular fashion, meaning that you should see that when you look at this, they are meeting at 90-degree angles, and that's what makes them perpendicular. So that's what we found, and I just wanted to show that to you visually.